This is what translational research can look like. Here you see a paralyzed rat with its paws dragging on a rolling treadmill, no sign of walking. When we applied our neuroprosthetic system, electrodes on the spinal cord were able to restore locomotion in the initially paralyzed animal. And this was not a science fair stunt. An adapted protocol was developed and applied to human patients. And here you see one of them using the system to take a walk along the Lake of Geneva. So we try to improve the life of ill people, and we use animal experimentation to achieve this goal. I do believe, however, that scientists can and must do more to reduce, refine, and replace animal experimentation. And I don't want to talk about ethics, but we need to remember that a substantial part of our funding comes from public support. Here's a 2016 poll revealing that an important part of the population opposes the use of animals for research. So the public is demanding action, and we owe the public clear answers. So what can we do? And I want to give you a practical example. So I'm working on improving the neuroprosthetic system that you've seen in action in the videos by making spinal cord implants made out of completely soft materials that are better for the body. But how can I be sure, when I implant these materials, that they will behave as I expect? So I had an idea. So I'm working with primates. I took one of our animals and took an MRI scan of it, and I used it to extract information on the anatomy and on the movement range of the spinal cord. I've used then this information to fabricate synthetic replicas of the spine and the spinal cord. I then put bits and pieces together into a robotic system that mimics the real experiment, and this is the result. So we have an artificial version of the spine and the spinal cord that we could use to screen our new medical technology against potential failure mechanisms such as mechanical, electrical, chemical, thermal, etc. So the first point that I want to make is that it is indeed possible to design and create better medical devices without even stepping foot into the surgery room, or before stepping foot into the surgery room. But it can get better. So imagine now integrating other technologies into this platform, such as cell culture, organ on a chip. And you can imagine all of a sudden you can test for cytotoxicity or biocompatibility, maybe drugs. So I would like you to think of this as a small step towards a complete paradigm shift. Thank you.